Welcome everybody to this code walkthrough. Mike Perez here. I'm joined with Yuval, who's going to be speaking about Rados Gateway bucket notifications, specifically with AMQA and AFCA, if I got that right. And so, Yuval, will you please take it away?
Sure, thanks, Mike. Yeah, so I'll try to go through the code there and explain how the things are working. I'm going to share my screen. Second. Would appreciate, guys, if you tell me if you see the screen and if the font is large enough and it's clear enough. Look at the code.
Can you give it just one more bump? Just one more plus, and I think that should be good. Just want to be sure because of the compression on the recording sometimes.
Okay, 1 second.
Okay.
Okay, great.
Thank you. Yeah.
Sure. Okay, so just a couple of words about the feature itself. The feature is about sending notifications on actions happening on objects. So whenever an object is created or deleted, then we need to send a notification to a pre-configured endpoint that waits for those notifications. This is like really in a nutshell the feature. But I won't spend too much time on that because I want to go into the code. Couple of things before that. So the feature has two main modes. One mode is push mode, and this is pretty much what I've described, which means that something is happening, you send a notification, and there's something like AMQP or Kafka or just an HTTP server that gets those notifications. There's also pull mode. Pull mode is where all the notifications are stored in a special bucket, in a special zone called a pub sub zone, and things are being pulled from there. We plan to deprecate this mode in the future, so I would not touch that in the code walkthrough, but I'm still mentioning that because you're going to see a whole bunch of code that I would ask you to ignore, and I'm not going to explain, and this is why. This is the reason. Another kind of disclaimer, similar one, is that when we just started the feature, the API for the feature, for configuring the feature, was not AWS compliant, and it's also deprecated. So there's going to be a couple of explanations and things I'm going to skip and say this is the non-compliant API. We're not going to touch on that. So this is why I mentioned that at the beginning. Now, there are two main flows to the code. One is the flow where you provision or configure the bucket, the feature, the bucket notification, saying what are the endpoints and which buckets needs notifications on them and filters on those notifications and so on. And the other flow is when you actually do the actions like put object or delete object, then and a notification was previously configured, then I'm going to show the flow of what's happening and going on there. So this is kind of to map the different things that we're touching here. So I'll start from the flow where that describes the way that things are being configured, and these are the files that manage this part. And this is the RGW underscore REST, and we have REST pub sub and REST pub sub common. Again, the reason that we have both pub sub and pub sub common. So one thing, pub sub means bucket notifications here. Later on, when I talk about pub sub, this is specific to the thing that I want you guys to ignore. This is the pull mode, but for historic reasons or for whatever the file names say pubsub. So REST pubsub and REST pubsub common are the files that handle the configuration, and common versus the pub/sub is whether it's like whatever is common to both the compliant and non-compliant definition of the API, and this is why we have these two files. So just to see what are the thing there. There's something called a topic. A topic is a definition of an endpoint, and you have REST APIs to create a topic. You can see this class. We have REST API to list topics and to get a specific topic and to delete a topic. Those are the different APIs here. Now there's something called subscriptions. I'm going to skip on all the APIs that has to do with subscriptions because the subscription is exactly the real pub/sub mode where things are stored inside Ceph and being pulled from the outside. And this is something we want to deprecate, so I'm going to not look into these. And then the next set of important APIs are the notifications. Now, notification is what glues a topic, which as I said is like the endpoint, definition of an endpoint, with a bucket. So notification glues those things together, and on top of that also provide specific filter of saying, like, not only that whenever I'm getting any change I want to send to a specific, let's say, Kafka broker, it also defines some filter saying, I'm just going to send all the creations or all the deletions, or I have even more fine-grained filtering that you'll see later on saying, I want to send creations only on objects that start with X. So all those definitions and configurations are part of the notifications. And we have the set of APIs here that we can create a notification, we can delete a notification, or list all the notifications. So this is really in a nutshell those definitions of the APIs. Now the actual implementation of those APIs, I mean, there are maybe a couple of things there that we need to look at. So for example, when we talk about the so all the configurations, everything, they're stored as system objects. So when you say a topic, it's really a system object of a topic. When you say identification, this is a system object of saying all the identifications that, or the glue between the topics and the specific bucket. So all that stuff is being implemented in another set of files, and I'm going to show them in a second. But this is what you would see here. So if you look at the actual implementation of the REST APIs, then, for example, let's say the create topic execute command, which is what creates a topic, you would see that it uses something called create topic of an object that we'll see later on that actually creates the system object and everything. So this is this file. This is the file that deals with the compliant interfaces. So when it talks about writing the system object, it doesn't matter whether this is the compliant or the non-compliant API. But when we talk about how to extract the parameters, so the get params functions, then it is different. And we'll just go through the compliant API. So this is kind of pretty much the structure of those AWS commands. Those are post commands, but their parameters are not encoded in the URL. Their parameters are encoded in the body of the message and extracted from there. So all the different parameters, you extract them for here. There are a couple of special cases. For example, when you define an endpoint, then this endpoint, let's say Kafka endpoint, we might require, whoever configures that may require that this endpoint uses some secure communication or uses a password. in order to log into this endpoint, and we want to prevent from anything like that to leak. So we don't want to allow any configuration of secrets over non-secure interface here. So we check whether there are any secrets in the message, and if there are, we want to make sure that this was over a secure socket, and otherwise we're just going to say this is incorrect. Don't do that, and we don't configure anything over insecure socket. There's another set of special cases here, and this is for persistentifications. This is still a different type of identifications, but we're going to touch that later. And this is pretty much it. So what you would see is that in this file, where you have compliant APIs, then you would see that the get parameters is different, but the actual action of writing the system object holding the configuration is the same. So this is why it's in the _common file. So this is just to map those things. And any questions about the configuration mechanism? You can do some of the not actually creating stuff, but you can fetch stuff also from the Redis Gateway admin command, but they're calling directly into those internal APIs, the PubSub ones, so they're not going through this REST interface. So the next thing we're going to look at is what we said is the PubSub one, and this is the actual structures and interfaces that stores the information that is configured over REST. So RGW PubSub.h is where the structures are defined, and in those structures there's quite a bit of legacy from the pull mode or from the PubSub mode. So I'll try to kind of put notes here and say don't look at that. This is not important for now. We can just go through the different objects that we're storing. The KeyFilter is what I said. This is the data structure that holds whatever do further filtering. So the basic filtering is based on type, like I just want to get notifications on object creations or object deletions or object copies or multi-part upload or stuff like that. This is like the event type. But then there's further filtering based on object name, prefix, suffix, and regular expressions. And this is being held here as the filter. And there's another set of filters that is based on tags and attributes, and you can also use these, and those are like key map filters, and saying that I just want to get notifications if the object tag is named X equals Y, or I just want to get notifications if there is an attribute that with certain names it has certain values. So this is another set of filters. And overall, you can have a key filter, which is based on the object name, which is a prefix, suffix, or the regex. You can have this is the attribute, the metadata filter, and you can have tag filter. So overall, you can have a combination of those filters, and those are stored here in this object. This is the API syntax. This is how those are filters being sent. By the way, those filters are not supported by AWS. AWS, I think, just have the suffix rule, if I'm not mistaken. The prefix or maybe suffix and prefix. Anyway, the regex and the metadata and tags are our extensions to this. Now, there's something called notifications, and you saw before that the REST API has like a create notification, and after doing all the getting all the parameters and from the REST message, you need to actually call the the function that stores this notification inside the system object, and this is the structure of notification. So there is an ID for notification. This is useful when you want to later on delete a specific notification. And you have events. This is what I said. This is the basic level of filtering, puts, deletes, copy, and so on and so forth. This is the, as I said, notification is an association between a topic and a bucket. So this is the name of the topic that this notification is being associated with. And this is the extra level of filter, as the prefix, the regex, the suffix, or the tags and metadata filters. So these are the data structures. Another important data structure that we have here is the events that we're sending. So overall, there is the notification event and information that we're sending. This is mainly metadata on the object that something happened to it. So this is the structure. Again, it's a standard taken from the AWS structure of messages. There's information here that combines kind of both information about the transaction, so where we got this request from, and also information about the actual whatever happened. So the buckets and the objects and all kind of things like that. So this is the information that we're sending. Now, this is the data that is being held here. Now, in general, we don't need to store this. I mean, as I said, in PubSub, we store those events inside Redis objects. But usually in the case that we were talking about, we're just sending them over. So this is why actually this bufferless encoding is not very useful. What is useful, or more useful for our case, is that we have JSON encoding, and this is what is sending those messages to whatever endpoint on the other side. This is the old event, so we're not going to look at that. Now, this is the definition of the endpoint that we want to send to. The bucket name and OID prefix, this is only for the PubSub case where actually the endpoint is a bucket that we're storing the information. So those, you can just ignore them. And what is more interesting for us is that who we're sending the messages to. So we have the push endpoints and endpoint arguments and the topic ARN. We also have two flags here that characterizes the topic, and this is the whether it stores a secret, because as I said, this is important. We don't want, not only that we don't want to allow anyone to configure a topic that has user and password in it if it's not over SSL, we don't want to allow them to fetch them later on. So if somebody is want to fetch a topic or get the list of topics over HTTP, and we know that those topics have stored secrets, we're not going to reply to them. So this is why we're storing that here. And persistentification is something special that we also need to save here as information. So the name of the structure is really misleading because it should have been just called RGW PubSub topic or topic dest, but it's called subdest because of those historic reasons. But this is really the definition of the topic that we've seen before. This is the definition of a notification. So it includes the ID of the notification as well, and yeah, those are like the non-compliant. So okay. Okay, so we've seen the REST messages or the REST structure and the data structures. And I want to go now and have a look at what we do with them. As I said, we want to store those objects as system objects. So, and this is in the file RGW PubSub. Those are for XML. So in the header files, we have all the buffer list encoding and decoding, and this is to store the configuration in the system objects. Here we have lots of XML encoding, and this is because when somebody is want to get those messages, we need to encode them in XML because this is the API over REST. So we have lots of functions here that does the XML encoding for those things, and there should be also JSON encoding for the big notification structure because this is encoded in JSON when we send it over. We have here functions that does the matching. Those are the matching. This is the matching logic of saying whether a specific value needs matches the filters that were defined. We check all the filters, the prefix filter, the suffix filter, the regex one, and we also can check the key value filters. So there's also checking here, like as I said, the first layer of filtering is based on the event type. So we want to make sure that when we have match for the event type, which means that we even care about this specific event for those notifications. Yeah, this is, as I said, the JSON encoding that we have for the event or for the notification being sent over. This is the big structure that we've seen before, and this is being JSON encoded. Okay, now we get to the actual writing and management of those system objects. So we have one object, which is a global object that holds all the topics. It is global, but it has in its name, we append the tenant name, so it's global per tenant. But per tenant, we have one global object and holding all the configurations of all topics. So this is we have a read topics and write topics. And this is to get this information. Now, the way that we manage, and this is a little bit confusing, the way that we manage notifications, as I said, notifications is what ties the what ties the topics to the buckets. So we kind of call them, instead of calling them notifications, we call them topics, but they're stored per bucket. So those are like bucket topics. So whenever you see here in the code the term bucket topics, this is actually notifications. So if we're gonna jump for a second to the definition, so it is a list of topics with filters, and because it is stored per bucket, so it's an object per bucket. Those are bucket topics. So we don't have, so as I said, for the topics themselves, we have one global object that is holding the topics for the entire system. But for the notifications, we have an object per bucket because it's the association of the topics to a specific bucket. But it's also have in its configuration, it has those filters that we mentioned before. So this is why when you see the structure here, then it has the the string. This is the ID, then the notification ID that we mentioned before, because we want to be able to delete a specific one. So you're going to have this kind of structure going to be stored in an object per bucket, and it has all the filters. And if you want to read those topics, so we have a read topics here, but this read topics read all the topics from the global object. This read topics read all the topics from the bucket specific topics object. So it will just get you the notifications of this specific bucket. And this is similarly the right one to write a topic to a specific bucket, which is, in other words, create a notification. What else? Okay, so this one is probably the more complex function here, and this one is the one that creates a notification. So when you create notification, you actually associate a topic, the events, which is the first layer of filtering of this notification, then this optional filter that has all the special stuff regarding key names and metadata and tags and so on. And the first thing that you do is that you verify that this topic indeed exists, because if it doesn't exist, then you cannot create notification. And then it reads the topics from the bucket. So it reads the existing notifications from the bucket, and then it adds them to this list of notifications of the bucket. So this is the process of adding a notification. Writes them back here. And if we got this special filter, we also put the filter in. Similarly, there's a remove function that takes out a specific notification from the bucket. And you can also remove all notifications of a bucket. This is very useful, especially when we talk about, if you delete the bucket, then you don't want those notifications to remain. You do want to do a complete cleanup for everything. So this is an easy way to remove all notifications of the bucket. Here's the function to create a topic. This is kind of simpler because there's a one global topic object. You read it, you create the new topic, and then you write it back. You can also remove a topic. Yeah, now these are the subscriptions, so we're not going to look into that. Those subscriptions are what we said is this pool mode, the pub sub mode, so we're just going to ignore them. Okay, so this really summarizes the part of how to configure topics and notifications. So this is like really the flow of configuration things, and this is done beforehand, and that's it. So now, I mean, if you have questions about this part or something wasn't clear, maybe this is a good time to ask them, because the next part is going to be about the process of actually sending notifications and what's happening when the Redis gateway is running and getting ops. So that's going to be a slightly different thing. So I'll be happy to see any questions now.
Don't see any in chat, so I'll keep a lookout.
Yeah. There was a question if it's possible to configure that from the console. Okay, so what I've shown before, those REST APIs, I mean, sure, you can send those REST messages, but handcrafting those messages is usually very difficult and not recommended. But you can use the AWS CLI command or O-Border3, which is pretty much the same code, to do that. They would craft those REST messages and send them over, but those are just command. Now, the reason that I recommend to use AWS CLI and not not like the S3 CMD, is because some of those APIs are not S3 APIs. For example, creating a topic is an SNS. An AWS SNS API. So S3 CMD, if you use to this tool, won't really help you with most of the things that are needed here to do this configuration. But again, crafting those messages by hand could be quite difficult, and it's probably better to use those tools. We don't have commands, we don't have like a Redis Gateway admin commands to configure those topics and notifications from Redis Gateway admin. We do have Redis Gateway admin commands to fetch the configurations, just to make it easy to see what's going on. But there's no, you cannot configure them through the tool. So hopefully this helped. Okay, so if no more questions about the configuration process, we'll go through the actual process of things are happening. So things are starting from RGW ops, which is where most things are starting anyway. And what you would see inside RGW ops, you would see in many places okay, so you would see two main functions being called. One function is called PublishReserve, and another function is called PublishCommit. Now, why we need those two functions in order to send notifications, I would explain when we talk about persistent notifications. But in theory, you just need one function to send those messages out, and you would see those functions in many places. For example, because we want to send notifications on many things that are happening. So, for example, in this RGW put object execute, which is where all object uploads or most of them are happening, then we want to get notifications in some cases. So I'll show one simple flow. Let's say that's starting from here, and see how things are working. For now, it won't be 100% clear why we need the reserve and commit commands, but when I speak about persistent notifications, maybe that will be clearer. So let's look at what's happening when we have like this put object. Okay, so we're calling here PublishReserve, and which means that we make a reservation for notification. We're not sending it yet, but we're giving it all the information that we need in order to create notification. Now, what kind of notifications? Well, we need to tell the notification mechanism where we're coming from, because the calling function only knows where we're coming from, and we also need to provide all kind of information about the objects and the request. As I said, when we send a notification over, both the filtering needs to know what's going on here, like what is the request and what is the object, because some of the filters are working on it. But only that, the information that we're sending over is consisted both from information on the bucket and object, but also information about the actual transaction, the S3 transaction. So this is why we kind of passing this information over. So we're passing a pointer to the object, and we're passing S, which is a short name for a huge structure, which is where all the request state is, and we're telling that we're doing an object put. And let's see what's happening with PublishReserve. Oh, it's not working, but anyways. So PublishReserve. So this is the function that we just called, and this function, as you can see, it gets all the information that we need about the object and the transaction. First thing that we do is we need to get the topics. So as we said before, when we did the REST provisioning, we stored the topics in an object. So we stored the actual notifications in an object. And these are the bucket topics. The bucket topics, as we said, is a different name for notification. So those are the topics together with their filters for this specific bucket. Now, we know what bucket we're talking about because this is information that we got from the message. So you would see that we have this bucket here, so we know what the bucket is. And now we read this topic. Now, maybe, there is nothing there. So this is fine. But if we did find topics that are associated with this bucket, then we need to go further and figure out if we actually need to send notifications on them. So we're going through all those configurations, all those bucket topics, and if you remember what you've seen before, those have filters, and those also have the name of the topics associated with them, and we need that because later on, if we want to send somewhere, we need to know where to send to. But we'll start with the filtering. So here there is the first kind of question. We have persistent notifications. The persistent notification are asynchronous notifications that are not being sent immediately. They're sent later on. So we're going to skip that for now. And if this is not a persistent notification, then this whole process of reserve and commit is not very useful. So the only thing we're going to do here is say, okay, the process is that if we found that this notification is relevant, and this is done the matching for the filter, then we're going to put this inside or store that inside this data structure, saying later on when you commit, you use it, just send it. If we're sending asynchronously, there's a whole other thing to do here, but we're going to skip that for now. So for the synchronous or regular notifications, we're going to look through all the notifications or bucket topics as they're called here. And if they match, which means if the parameters of the request and tags and names and events and all that stuff matches the filter that was configured, then this one is good. If it's not going to match, we're going to just go to the next notification, maybe the other one match. If multiple is going to match, then we're going to put multiple of these, because it could be that for a single op, let's say one upload, you have different filters, and those filters are sending to different endpoints, and this is valid, this is okay. So in the regular non-persistent notifications, we're just going to in place or put those configurations in a list, and later on, if we go back to the ops, later on, this reservation object is going to hold all the notifications that match the filter, and what's going to happen here is that we're actually going to do, like, this is the actual ops, like doing the actual work. And after the actual work ends, and that's going to be somewhere down here, after we finish, doing all the uploads or whatever we actually did with the ops, then we're going to do the publish commit. So here it seems a bit stupid that we split those two functions apart, because the first one went through all the talks, read the configurations of this bucket, went through all the filters and checked if any of the filters that fitted, stored that in a list here, and then when we do the actual commit, we're actually going to send it. So doing the commit. So here we get to the publish commit, and here we're going to go through the list of of topics that we stored, the one that matched the filter. And and then again, if it is persistent, we're actually not doing the actual sending because somebody else is doing the sending, so we're going to skip that for now. But if it's not persistent, then we actually want to send it. So the first thing that we do is that we create an endpoint, because we have in the configuration, as I said, we stored everything that was relevant in the list. And we have the configuration of the endpoint, and we create the endpoint. Now, the endpoint here, from our perspective, we don't care. Like, it just had something a function that calls send to completion, and that's it. But the actual creation of endpoint can create different kinds of endpoints, and this is really dependent with the configuration. So the endpoint could be an AMQP broker or a Kafka broker, or could be an HTTP endpoint. In the future, we can have more and more endpoints. So this is a different system that we have for endpoints, and this is a different file that handles them. But let's say that this factory function created the endpoint for us. So once we have the endpoint, then the only thing that we need to do is to send the notification to the endpoint. So whatever mechanism we have there for this sending, it's going to be used here. Now, this is asynchronous sending in the sense that it uses the yield mechanism in order to make sure that we're not blocking here until we get the answer. And this is kind of, we are blocking this specific coroutine. So inside the ops, if you assuming you're using a BIS front end, then every ops has its own coroutine, and this is synchronous inside this coroutine, but we're not blocking other coroutines that could be running and doing other things at the same time. So inside this send to completion async, it means that whatever mechanism that we have, let's say Kafka, then we're going to send to Kafka. We're going to wait here until we get the answer from the Kafka broker that the identification is safe and sound inside Kafka, but we're not going to block other ops running in parallel, doing other things. So this is what this send to completion async means. It does mean that we're synchronous here in this specific coroutine. And this is one of the reasons that we had to add the persistentifications or the async notifications, because, for example, if the Kafka broker is down, then we're going to wait here until we get a timeout, and this could take some time. And it means that even though other requests can go on freely, this specific request is going to really wait for a long time here and block the entire system. So this is why we had persistentifications. I'm going to explain that later. But overall, the basic flow here is that we have the PublishReserve function, and this function is the main thing that it does for non-persistent notifications is going through all the notifications of the bucket topics, getting their filters, see if those filters match, and if they match, it just puts everything in this list. And later on, when we're done with the actual op, writing the object or deleting or whatever, then we're going to call the publish commit, and publish commit is going to go through everything that was stored here and create those in the non-persistent case, create those endpoints and send them in a synchronous way or synchronous per coroutine way, those notifications. Now I'm gonna not sure I'm gonna have time to look at everything, so I prefer to have a little look at the persistentification, because this is a whole different mechanism. So I don't know if you remember, but at some point when we did the configuration of the topic, so if we can look at then there is. So this is the function that gets from the REST message the create topic. And one of the parameters of creating a topic is whether this topic is persistent or not. Now, I'm not going to go here through a whole explanation of persistent notifications. Maybe if you do want to learn more about the persistentifications, then I have a blog post. It's not really about the code; it's about the kind of persistentification, how the mechanism works, and all kind of things about that. So I'm just going to paste it here. And if you want to have a look, then you can have a look at it. But if somebody defined the endpoint as persistent, it means that the coroutine that is initiating the sending or the publish commit command is going to return immediately. It's not going to wait for the actual answer of ACK or NACK from the Kafka broker or MQP broker or anything. So it's going to return immediately, which is better for the clients because the client's not going to wait in case the broker is down. And also better because we also have a mechanism for retries because it's done asynchronously. Then there's a mechanism there that does retries. And the last thing that is good, and this is kind of explains why we need the reserve and commit, is that we have some kind of atomicity here. Because if you look at, if we have the case of non-persistentifications, then, let's say that we failed. Now, all the lines before here, we upload the object is already in the system, everything worked perfectly fine, but what if we failed here? So if we failed here, it's too late for rollback. We can't say, oh, we failed the entire action because the object is already in Ceph. So we can't say we failed, but the notification is not sent. So on the other hand, this is not good either because if somebody configured bucket notification, it means that they want notifications there. So it's a bit of a problem and it's not really solvable if this is done in one action. But if we split that to a reserve and a commit action, it means that we have better guarantees for the user. So if the reserve action failed, which means that no notification is going to go out because, for example, like we use a queue there, the queue is full or whatever, then we're going to fail the entire action. But this is good because this is before the actual object was put into Ceph. And if somebody wants notifications, they're not going to get them. They're going to fail the action. So somebody's going to try and upload an object and get an error back. But if this one was successful, it means that even if Kafka is down or there's some other issue or error, then we store this notification inside a queue and we're going to do our best, sometime in the future to actually send it. So the fact that we did this commit, which means that we're going to retry the message, and even if things are down, even if they're currently a problem, this is still going to be sent. So we're not lying to the user when we actually replying with a 200 OK for the operation, because it's like saying, maybe the notification is not immediately sent, but it's going to be sent sometime in the future when the Kafka broker is up. And this is why we feel better in this case. So this is why we have this split between the reserve and the commit. And if you want to look further into the details of how this is working, so this is here again in the RGW notify file, and now we're going to look at the if case that we skipped before. And for example, in the reserve case, if the configuration of the endpoint to be a persistent, then what we're actually going to do, we're going to reserve a spot on a CLS queue. So we have a special queue that is like a two-phase commit queue that we can make reservations on, and then we know we have space in the queue. So we reserve a spot in the queue, and if we made this reservation, that we know that things are going to be fine. And later on, when we do this, when we do the publish commit function, and we go look into this if of saying, what if this is a persistent endpoint, then instead of creating the, like as we've seen here, creating the endpoint and send to completion, we're not going to do that. We're going to know that we made a reservation on the queue, and And now we can commit this reservation, which means that, we have a couple of checks here, but overall, we're going to commit the reservation, which means we're going to write this. Here, there's some issue with the size, but overall, what we're going to do here is we're going to commit the reservation, which means that we're going to write the notification into the queue. Now, we just written into the queue. We didn't send to Kafka or anything here. And this is why we have a whole other mechanism that takes things from the queue and send them over. So in a second, we'll look there. There's also an abort. The reason that we may use an abort is because let's say that the action that we did in the ops failed for some other reason. So it could be that, Raiders failed to put the object. So in this case, we want to make sure that we do proper cleanup of the reservation, and this is why we abort the reservation. I see that I kind of run out of time. I'll have a quick glance at an example of Kafka and AMQP, just to show you around the files a little bit, and then I'm going to leave some time for questions and the actual mechanism of sending those persistentifications. I won't be able to do now. So the Kafka and AMQP ones, they have very simple, like if you look at the headers, they have very simple APIs. So they have an init and a shutdowns, because they have like a global managers, and I just want to init them and shut down them from the main function. So if you look at RGW main, you would see the init and shutdown of Kafka and MQP. And what is more interesting here is that this publish with confirm. And there are a couple of other functions here that you can, get all kind of stats and stuff like that. So if we look at the Kafka, so the Kafka has. We'll start with the publish with. So this is the function that is being called, and what this function does, it puts stuff into a queue, and what it puts into the queue is the message, which is like the notification, this JSON structure that we need to send, and the callback. And the callback is what releases the yield from the coroutine in the ops context. So this finishes quite quickly because it's actually asynchronous. It just puts stuff into a queue, and there is the internal thread of the Kafka manager that reads from the queue and sends over the Kafka library the messages, and then receives answers. It's all asynchronous, like the sending and receives, and bulked, and then releases those callbacks that actually releases the ops coroutine to continue with its work. And it's pretty much the same for Kafka and HTTP, the same kind of concept. Like when you do the publish with confirm, you put stuff into the queue, and on the other side of the queue, there's a thread that empties the queue, sends messages, then wait for answers, get answers, unlocks those callbacks, and so on and so forth. There's also like some connection management. You can have multiple Kafka brokers and manage here. So, every time there's a definition of a new connection, you create the connection. And then if you just send something to connection, you just reuse the connection. You don't need to recreate it and so on. Yeah, I'm sorry I didn't go through everything, but I want to give like 5 minutes for questions if you have. Or anything specific that you want me to extend on. Um, if no more questions, then I'm just going to maybe point to two other files that might be interesting. So there's this file that's called pub/sub/push, and this is what is creating those endpoints. If you remember, inside the case where we're not using persistentification, there was something that creates the endpoints, and it has like all kind of types of endpoints. So this file really configures like there's an HTTP endpoint here, and this is where the send to completion is defined. There is the AMQP endpoint, and there is also the Kafka. Yeah, the Kafka endpoint. So those endpoints are defined here, and here we have this factory that is creating them here at the end. So this is the create one that creates the endpoint. Now, it doesn't really create the connection and everything. This is done inside the Kafka and MQP or whatever managers, but this one is creating the endpoint type and returns that. And if anyone wants to, in the future, add new type of endpoints, then this is the place where you glue them in. So, you write your endpoint in whatever mechanism that you want, and then you define here a wrapper for the endpoint that you have. And the main thing that you need here is this send to completion async function. And this is the function that, in case of Kafka, does this publish with confirm to Kafka, and also is doing the yielding and waiting on the callback that we've seen before, that the Kafka, you see here, that the Kafka is releasing when it's getting the ACK from the other side. So this is where those things are being glued together. Yeah, so that's pretty much it. If you have any specific questions or you want more details, don't hesitate, please send an email and I'll try to get back to you. Hopefully.
All right, great. Thanks for taking the time again, Yuval, to talk with us about bucket notifications, specifically going through a code walkthrough this time. So appreciate your time. Appreciate everybody joining us. Have a good rest of your day or morning.
Thank you, guys. See you.
Thank you.
Thanks. Bye.